Good to have you there.
Hello, everyone.
Hello, hello.
So I can just start, right?
Yeah, you can start for sure.
Amazing. Yeah.
Present yourself.
Yeah. So hey, everyone. I'm Dennis, and I will be basically introducing Mina protocol in O1.js, and also I will be walking you through building a project on Mina for the hackathon. So yeah.
Are you
So
coming
first
to
of
East
all,
Global? Are
sorry.
you are you coming to East Global personally?
Yeah. I'm currently in
Nice.
Bangkok as well. So yeah,
Okay, nice.
looking forward to meet you all there. And
Nice.
yeah, as you may know, Mina is basically a layer one built on zero knowledge proof. So you can think it. So Mina is using a proof system called Kimchi, and the most powerful feature about Kimchi is infinite recursion because it enables you to verify proofs in a recursive way. And the Mina protocol itself is actually a blockchain, just a bunch of recursive zero knowledge proofs. So once you do a transaction, instead of doing it on chain, you just put up, send a proof of it, and if the proof is valid, then it's get added to the recursive, proof. So that's how Mina protocol actually works. But we will be getting more deep diving there as well. And this also enables you to have have successness, which means having the blockchain itself as a single zero knowledge proof. And with this powerful feature, you can do stuff like running a full node just on your web browser without any hardware or computation dependencies and stuff like that. So Mina's the KAP model is a bit different than the Ethereum. So in Ethereum, Ethereum smart contracts execute on chain, and when you send a transaction on Ethereum, it sends a request to all network nodes to store and run your code, and every node executes these instructions basically to it yeah it every node executes your instruction code, then it leads to high cost and inefficiencies and stuff like that. But on Mina, actually every smart contract execution is off chain, and it's done on the client side, which we call client side zero proving. And this the contracts run in the user's browser written in TypeScript with O1.js, which I will be explaining later on. And also, the user runs the TypeScript code locally and generates a zero knowledge proof that verifies a computation. And then they send the zero knowledge proof with the state updates to the Mina protocol chain. And the Mina protocol verifies the proof. And if it's valid, then the state of the chain is updated. But if it's not, then the transaction is rejected. So unlike Ethereum, the full program does not need to execute on all nodes. Instead, it's basically just a way of doing the computation off chain and verifying on chain. So this has a lot of advantages. So the first one is privacy, of course, because you do everything on your local machine instead of doing it on a blockchain itself. It enables applications where data stays private, and it still proves facts about anything, basically verifying the credit scores without revealing the credit scores itself or use cases like that. And the other one is, as I mentioned, being succinct, which means it's only a 22 kilobyte consensus state. So wallets can verify the chain with full security, reducing dependency or centralized intermediaries like JSON RPC providers, for example. And it has a fixed fee gas model because since the whole computation is all happening off chain, fees basically depend on network demand rather than the computation cost. And it often means that the costs are lower to compare to other chains. And yeah, so how does this work actually? So for a transaction on Mina, you need a verification key, and deploying this key creates a ZK account. And with ZK app accounts, basically transactions are only accepted if they include a valid zero knowledge proof associated with the account's verification key. And basically it works in a way that, as I mentioned, because the whole computation of a transaction is just done on the browser, but you send the proof to the blockchain. And yeah, so O1.js is a TypeScript framework for building zero knowledge applications and also zero knowledge circuits in TypeScript. and it's also a ZK domain-specific language. So it enables you to use any tools that you have been using for developing TypeScript/JavaScript applications. It's the same concept, and it's this much simple to just start and initiate working on a ZK application on Mina. And the only difference is you just use TypeScript as you use regularly, but instead of using the normal variables and stuff, you just use the ones imported from O1.js because of the cryptographic primitives depending to it. So it's basically programming ZK and TypeScript. And let me just walk you through the bounty stuff and building a project for Hackathon. So for the bounties, we have two tracks. One of them is building a ProtoKit app chain, and the other one is building a ZK game using ZK-Node. So ProtoKit is an app chain framework which enables you to deploy your own app chains as a layer 2 on Mina. And and again, you do this with TypeScript. It's super simple. And ZK-Node SDK is actually using ProtoKit. So I would highly recommend you to check out their starter kit. So to have a quick walkthrough, what you need to do is you just need to clone this repo with a name, and you need to install the dependencies. And once you have done it, you will have a UI and a ZK application environment to build your own application chain. So as you can see, I'm just running both the web UI and the chain itself. So once it's gonna be ready, we will see the interactions. Yep. Yeah, I think it's still compiling. Yeah. And yeah, there we go. So as you can see, this is basically currently a UI connected to a app chain. And once you connect with your wallet, once I click on ref, it asks me to do like a transaction signature request. And once I accept it, it's sent. And you can also see it here, I guess. Yeah, yep. And yeah, here you can see the balance is incremented. And the way it works is, so here you see basically a simple balances ZK application. So you can think runtime methods as functions in Solidity. And there is a function called add balance to basically providing token ID, address, and the amount. And it increases the balance accordingly. So for your hackathon project, feel free to just fork this repo and just go into package, chain, source, and runtime. And the only thing the only thing you will need is this folder so that you can write any kind of your app chain ZK applications and put it here, and you will be able to just connect it with the UI accordingly. So for learning more about ProtoKit, you can check out their documentation, which is on protokit.dev, which explains more details about O1.js itself and building ProtoKit applications. And I would say ProtoKit's user experience is more similar to Solidity compared to O1.js. So it would be only like writing smart contracts with TypeScript and with ZK under the hood, of course. And there is another example, which is the airdrop example. So as you can see, here is a simple contract, I would say, like a ZK app, which is for verifying if a user is eligible for an airdrop or not. And the way it works is assuming that there is a Merkle tree which includes all the addresses that are eligible for a airdrop. It basically checks if they are eligible or not. And the way it works is here you can see there is a ZK program which is a ZK circuit. So there are two different concepts for building on Mina, which is ZK apps and ZK circuits, like ZK programs. ZK programs are normal ZK circuits, as you know, and ZK apps are actually kind of like contracts, but every function is a ZK circuit itself, and all the inputs you provide are public inputs. But what you can do is, once you generate a proof with your ZK circuit, you can verify in a ZK app that if this proof is valid or not. So in this concept, we have an airdrop ZK program where you provide a Merkle witness that your address is written in the Merkle tree of eligible airdrop addresses, and you basically verify that your witness computation is done correctly, and you generate a proof for that. And once you generate a proof for that, you send this proof to this claim function, and it checks if your proof is valid or not, which means if you're in the eligible addresses or not. And if you are, then it changes your balance accordingly. And one additional thing is it uses nullifiers to basically prevent double claiming attacks, which means if you just generate a proof like a Merkle witness without nullifiers, then it means the users will be able to just provide the proof multiple times and claim the airdrop reward multiple times as well. But to prevent this, you should use nullifiers to make every proof unique and filter it in that way. So yeah, we will be also creating a Telegram group for Eat Global Bangkok. So feel free to come to our booth, and we would be more than happy to add you to the group. And I think yeah, the only thing you need to start for building on Mina for the hackathon will be the starter kit. And yeah, thank you for listening.
Thank you, Denise. Nice.
Thank you.
Okay. I know someone want to build on Mina. Do you have, by the way, some application like a wish list about what you want to see at H.E.R Global?
We currently have, like as I mentioned, we are currently giving 20K USD bounties, and 6,000 of it's gonna be for ZK gaming. So we have a gaming SDK called ZK and feel free to use ZK for building ZK gaming products on Mina, and the other 14,000 will be just basically for any kind of use case. And we currently have like an ecosystem wish list, but I would say it's not really feasible in a hackathon time. So yeah.
In general, which yes, which I don't know the term. Which protocol are you like at H.E.R Global? We have some projects, so with Mina, we can build on which protocol as well, like to
Yeah.
cross bounty, you know.
I think yeah, I think you can use Mina for like leveraging more like use cases that you cannot easily achieve on Ethereum. For example, the powerful feature about O1.js is the way it's abstracted enables you to build applications with true privacy in a really simple way. So you can, for example, utilize Mina for privacy features, especially on Ethereum, because what you can do is, for example, you can verify signatures that are signed by Ethereum wallets, like for example ECDSA signatures on Mina, and you can also use Ketchup 256 hashes on Mina as well. So you can basically to enable to have like cross bounty, you can use Mina in that sense.
Okay, and are you compatible with Evi?
Um, it depends on the use case, but I would say like we are compatible with Celestia, but I don't think there's an integration with Avail yet.
Okay, because if you have a track related to gaming, I know that availability layer can be probably useful as well. So, okay, I know as well that Cartesy and Havai created a, a bounty together. So if someone build something on Mina related to gaming, probably take a look at as well Cartesy and Evi. If you can do something together, I don't know. Do you have any question? I think just someone looking for to build on Mina and want to team up with some people for H.E.R Global. And yeah,
Yeah,
you need Telegram.
we will be creating it in during at the beginning of the hackathon. And Freddy, feel free to just find us at the hackathon booth. So we would be happy to just trying to find your group. to hack on Mina as well.
Okay, nice.
Yep.
All good. Thank you very
Thank
much
you, Solly.
for your
Yep. Have a
presentation.
great day.
Yeah, you too. Bye bye, everyone.
Thank you.
See
Bye
you.
bye.